Roughly speaking, and greatly simplifying, one can say that any body consists of atoms and molecules. Roughly speaking, we are only interested in atoms. Atoms, as we remember, there have been a lot of videos on the channel about this, links will be in the description, watch and recall. Atoms have, well, let's say, a planetary model, although it's not exactly like that. The planetary model implies that we have a nucleus of the atom, and electrons are located around the nucleus. Electrons are in constant rotation, and we remember this. And again, it's not exactly like that, but for explaining magnetism, this will be enough for now. So, electrons are moving. And we remember that when there is movement of electric charge, what inevitably arises around it? Well, the electric field, of course, and a magnetic field also appears, and altogether, this will be an electromagnetic field. But the thing is, when we have current flow, there is always, roughly speaking, a magnetic field. This again, if we omit many complex details, which we don't really need right now. Particles move, particles are in motion, and each particle creates a magnetic field around itself. You might ask here, why then, let's say, the radiator of the battery does not magnetize objects? Well, first of all, everything is relative. It is, in principle, capable of doing this, to some extent. And, secondly, it is very important to understand that, apparently, this property is not the most important. So what is the most important thing then? The main thing is alignment. Now let's return to the picture we described. Let's take some atom, around which there is a moving, I won't say rotating, electron. When there are many such atoms, the electrons start to move, as a rule, chaotically. When our electrons move chaotically, our magnetic fields are not aligned. But if at some wonderful moment, our electrons coincide in motion, and the movement of the electrons is aligned, then they will have a common magnetic field. And this magnetic field will be formed thanks to the work of each particle present in this material. In ordinary materials, such effects are in different directions and unsynchronized. But in permanent magnets, the specificity of the material from which a permanent magnet is made, roughly speaking, lies in the fact that these little electrons start to rotate. Again, remember, there is no actual rotation of electrons, but there are some movements of theirs. And this movement is what we are analyzing. The word rotation is not entirely appropriate. But this is not particularly important to us right now. What matters is that in the case of a permanent magnet, electrons move, rotate, however you want to say it, synchronously, their direction coincides, and it turns out that we form, so to speak, the magnetic properties for the permanent magnet.